What enables companies to move faster is true, real-time visibility of their physical world. Keeping people and machines on time and on budget is a difficult task. This is why drones are becoming adopted to provide real-time visibility. But today, decision-making is still manual and requires input from humans. In the near future, decision-making will be interpreted by AI. Skycatch is realizing this vision with our partners Komatsu and their intelligent machines. Skycatch has developed artificial intelligence to analyze the growing amount of data generated all over the world. Skycatch AI will process live data and predict when schedules are at risk. Future job sites will use supercomputers in the sky, working with advanced smart machines on the ground. The Skycatch AI will get smarter over time and will become as complex and dynamic as the job site itself. This allows Skycatch to rapidly scale the same functionality across millions of job sites.
Hello, everyone. Just want to record everyone real quick. This is for my team. I'm going to tell you a little bit more about what this is towards the end of the presentation. How many of you here are familiar with drones? Raise your hands. How many of you actually own a drone? All right. How many of you are familiar with artificial intelligence? How many of you have actually trained a deep learning model? Oh, wow. Pretty technical team. What we're going to talk about today is how are we making these amazing machines smarter, and why are we making them smarter? Skycatch was started about 4 or 5 years ago. It was just me and a couple of guys going to job sites, trying to figure out to see if the data that we were capturing was actually useful. Through that process, we found that a couple of people were asking for data on an ongoing basis. It was just video and photos. 2 weeks later, we were on high demand. They were asking for these videos and photos almost every single hour. That's what started Skycatch. Today, the company is headquartered in San Francisco. We have offices in Mexico. We have a small team in Hong Kong and a small team in Japan. We have about 60 to 70 engineers, mostly engineers, not all engineers, but mostly engineers. And our core strength is not really building drones, but it's AI, machine learning, and computer vision. Since day one, we've been highly focused on making sure that what we build is actually useful for our customers. Today, we're proud to be deployed in over 10,000 locations and projects all over the world. One in particular that I'm very proud of is actually in Cupertino. So it's the fastest, most incredible building that we can't talk about, but you can use your imagination. We've been deployed there since day one. And the reason they're using us is because they need high visibility to make decisions very fast. Some of our partners is Komatsu. They use our technology to automate bulldozers. If you look up Komatsu robots, you'll see articles about that. We partner with DJI. We are the first company to ever manufacture in their facilities with another brand. That means Skycatch branded drones are being shipped directly from DJI facilities. And Goldwyn is one of our recent investors. They just put in close to $9 million to help us expand our technology on the inspection market. NVIDIA, we all know NVIDIA is basically powering AI with their incredible hardware. A quick view, a snapshot of the market, just to give you some context and some perspective. There are about 15 million job sites active every single year all around the world. That number is just going to get bigger and bigger over time. As we start moving faster, getting more efficient, as we start introducing more robots, we'll be able to build faster, and that number will triple, or not quadruple. There are more infrastructure today than humans are able to properly maintain, and that's just a fact. Bridges, dams, solar farms. We're growing so fast, we've gotten really good at building, but we're not really good at maintaining. And that's something that goes side by side with technology that we're developing and technology other companies are developing as well. The biggest bottleneck that we found, and this has been since the Industrial Revolution, the biggest bottleneck is humans. Humans are the ones who are understanding the information or interpreting information and connecting it to a project task or to a new deployment or to organize new resources. Always humans are in between some of these decisions. That's why what we've done is through the use of UAVs and use of AI is try to bypass the human element. For instance, I'll go into how we're using AI to predict what kind of missions you're going to have in the future. Today we have a strong dependency between humans and machines. We believe the future is going to be when machines are able to talk directly to machines, and machines have full context of what's happening. Not just simple, narrow AI, where you train a couple of models, but full context where every model is related to each other. And I'll talk a little bit more about how AI works. A lot of people don't know that AI, the reason why it's becoming so popular is because you don't need to hire engineers to develop innovation. You actually just train your models and deploy them. It's far more complex than that, but a lot of the algorithms have already been written. So in my industry, this is what today looks like. The past, it's on the left side, is what today looks like when it comes to trying to understand the physical world. You have to understand the physical world if you want to build things on top of it, or if you want to change things on the Earth. So today we use surveyors. That process takes about 2-3 weeks to survey a medium-sized land. With Skycatch and many other technologies, that innovation is reducing that time to about 10 minutes to 15 minutes. That is incredibly revolutionary because you need that data in order for you to start developing and building more. The machine-to-machine evolution is happening already. Today, we are deployed in over 5,000 job sites in Japan where the drone technology is communicating directly to a bulldozer. So a bulldozer gets the data from a UAV, and the bulldozer then goes in and starts moving the earth, and then through stereo cameras, it recreates the land, and then it constantly communicates with the UAV to find out what it's going to do next. This whole innovation will require enabling smart machines all across the board. You can't just do that with a UAV. You have to make the bulldozer smart as well. That's where this unit comes in. So imagine every machine that you see out there, trucks, pickups, cars, everything out there that moves, including refrigerators, everything that we built since the Industrial Revolution. This unit right here, the attempt to build this unit is so that we can give a brain to all these machines that don't have a brain. So besides putting a brain on the UAV, we're working towards enabling and extending machines with a brain. This can connect to any sensor, cameras, speakers, you name it, and it will enable machines to become smarter and communicate with the rest of the machines. We strongly believe that in order to fully automate everything out there, you need to have full context. Not only a bunch of really good smart models, but full context, meaning a machine will know the weather, will know the schedule, when things are going to be delivered. And that doesn't require AI. all of that is going to be part of the context that is going to be integrated into AI at some point. We're starting to see that already with Komatsu, one of our partners. And we're seeing it with other companies that are looking into it. So artificial intelligence is not just a buzzword. People are actually implementing this in real time every single day. People think about Tesla as a car company, but it isn't. Tesla is actually an AI and battery storage company. I say AI because if you have a Tesla, how many people have a Tesla? Not many people, but if you see a Tesla driving around, they're actually learning as you're driving. The labeling process happens when you're pushing on the pedal, when you're stopping, when you're turning. They're actually labeling data and doing the training in real time in the car itself, and then they're synchronizing that data back to their cloud, and then synchronizing it across all the cars out there. That's how they're learning. That's how they're making their machines smarter. Battery storage is another place that we have a lot of strong passion for, because that's going to enable a lot of these smart machines to last for a long time out there. How does artificial intelligence actually work? I said earlier that you don't have to hire an engineer to do, you do, but you don't have to do coding to do artificial intelligence. You have the minimal coding, but most of the coding is already done. What you need to do is training. You need to train smart models. How it works is you get lots of data, you tell the machine what is what on that data, and then you start letting it train itself over time. So for example, on that slide right there, we were able to break out hundreds of videos from YouTube, label them, and that generated 120,000 frames, and we used that to train a network to identify machines, what they're doing, and all the parts on the machine. This is something that we're deploying in Japan in collaboration with Komatsu. That's not necessarily a drone. It's actually feeding data from a surveillance camera. So it's very simple. You capture the data, label data, you train the models, and then you synchronize that with your machines on the field. Sounds simple, but once you get it working, you can scale it. For example, one of the things we're working on with DJI is so that this machine right here knows on its own what missions it needs to do. You don't have to program it before you go there. You have to lay it on the floor, make sure it has batteries, and it takes off, and it knows what missions it needs to do. Why? Because it has more context. It has information about schedule, deliveries, and once it goes in the air, it records video, enough video to create a report of what machines are idle, what machines are moving, and it correlates that with context about at what time we're supposed to get more material, at what time we're supposed to deliver something. This gives us the ability to completely remove the human element from this process. Scaling it is the challenge. How is Tesla deploying thousands of smart machines all over the world? Is by efficiently maintaining the learning process of each machine and synchronizing that into a central place, and doing lots and lots of testing. Replicating this, you'll be able to have the equivalent of a pilot on a smart machine being able to be deployed all over the world. These are the things that companies are asking for today. 3-4 years ago, companies were asking, can we fly and take photos? Companies today are asking, can we have this deployed in thousands of sites? This is the view of what it looks like in the future. You're not going to have people flying the drones. You're going to have people in a center looking at screens and monitoring all the data being collected and the learning that's happening in real time and what kind of progress is happening across the board. You're not going to see a lot of people in job sites either. So now imagine with all of this innovation, what will happen 30 to 50 years from now? We strongly believe that all of this innovation, all of this automation, it's not scary. It's actually going to bring us true, full human equalization. It's going to be much easier, much more affordable to build things. Build a highway is going to be a piece of cake. Things are going to be a lot more affordable. Food is going to be affordable. All of those things are going to happen in the future. We believe that because we're seeing it already. Projects are taking less time. Cost of projects is much lower. What next? My big question for you, now that I share with you what we're doing, is what will your role be in this incredible revolution? I would love to see many of you, and hopefully maybe next year, companies implementing AI on the field and advancing technology in this space. And hopefully maybe 50 years from now, we will achieve total human equalization. Thank you, everyone.